Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at the evolution of spanning tree protocol. We'll be discussing different versions of spanning tree protocol, RSTP concepts, RSTP port states and port roles, PortFast and BPDU guard, and then finally we'll take a look at some alternatives to spanning tree protocol. This episode is part of my series on switching, routing, wireless essentials. I'm Kevin here at KevTechify. Let's get this adventure started. There are different versions of spanning tree protocol out there. Spanning tree, there's the rapid spanning tree, there's the multiple spanning tree protocol, there's a couple other ones out there. But the IEEE, the people that make these protocols, this document I have listed here, IEEE 802-1D-2004, it says STP has now been superseded by rapid spanning tree protocol. So rapid spanning tree has replaced the original spanning tree protocol. STP, that refers to that original implementation. RSTP, that rapid spanning tree, that refers to the updated version of that. Now, current standards in the Cisco's, for the current standards, Cisco typically uses the RSTP. They don't use the STP. Yes, RSTP is backwards compatible, but Cisco designs for that rapid spanning tree protocol. Now, Cisco switches running the iOS 15.0 or later, they use a PVST plus, a per VLAN spanning tree plus protocol. There are several different versions of STP out there. We have STP. This is the original spanning tree protocol back from 1998. It provided that loop-free technology, gave us redundant links. It's also called Common Spanning Tree, CSTP, or CST. It assumes that there's only one spanning tree protocol for the entire bridge network, regardless of the number of VLANs that are happening. Then we have PVST plus, per VLAN spanning tree plus, and now that's a Cisco enhancement of that spanning tree protocol, that original spanning tree protocol. It provides separate spanning tree instance for each VLAN, supports PortFast that allows it to skip the learning process and the listening process. That saves that 30 seconds of connecting in. It has a backbone fast. It has a BPDU guard, a BPDU filter, root guard, and loop guard. So it has some stuff built into it to stop some of the possible problems. 802.1D-2004, updated version of STP, incorporating some improvements from IEEE. RSTP, that rapid spanning tree protocol, is an evolution here of STP that provides faster convergence, so it happens quicker. Then we have rapid PVST. This is another Cisco enhancement of the RSTP. So RSTP was established by the IEEE organization. Cisco grabbed it, put its own twist on it, called it rapid PVST plus. We have MSTP and MST at the end. MSTP is multiple spanning tree protocol, IEEE standard here, inspired by Cisco's multiple spanning tree protocol. Maps multiple VLANs into the same spanning tree instance, so you can have multiple VLANs in one spanning tree instance. And then MSTP here is the Cisco implementation of MSTP. And once again, it's up to 16 instances. You can have multiple VLANs, combine them in. So there's all sorts of varieties out there of spanning tree protocol. Rapid spanning tree, that IEEE 802.1W standard, that takes over for the original spanning tree protocol. The terminology, basically the same. There's a couple tweaks in there. Most parameters have been left unchanged, so default values, settings, they're all the same. Rapid spanning tree, it increases the speed of recalculation. Meaning when there's a change in the network, when do we come to convergence? When do we have everybody's happy on who the root bridge is, what root ports are, designated ports, alternate ports, all those together. It just happens faster. Oftentimes it's a few hundred milliseconds, so way less than a second at this point in time. The alternate port here in RSTP, it can immediately change to a forwarding state. The alternate port is a blocking port. It can change to a forwarding state. It can change to a forwarding state as long as certain criteria has been met. And of course, Cisco took this and put its own twist on it. That's that PVST plus. It's basically rapid spanning tree, but it's on a per VLAN basis. Independent instances of the rapid spanning tree run for each VLAN. So for every VLAN you want this rapid spanning tree to have, you need to run another instance of RSTP. Every time you run another instance, it takes more processing power, takes more RAM. Could slow down your router some. If you like this episode on the evolution of spanning tree protocol and you get value out of it, and depending upon what platform you're using, please click that like button, give a 5-star rating, subscribe to my channel, leave a comment. Doing this supports the channel, which in turn helps me bring you more great content. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Looking at the RSTP, the Rapid Spanning Tree Protocol, port states and port roles. If we look here, we have in normal STP, we have our 5 states: disabled, blocking, listening, learning, and forwarding. In rapid spanning tree, we only have 3 states. The learning and forwarding are still the same, but in rapid spanning tree, we've combined the disabled, the blocking, and the listening states all into a discarding state for rapid spanning tree. Also, port roles. For port roles, for spanning tree protocol, we had 3 of them. We had the root port, the designated port, and the block port. The non-designated port, the alternate port. RSTP adds in a backup port. And that backup port allows for the quicker calculations of when there's a change on our network. When there's a change on our network, it goes through the process, but we also have some backup ports that were established earlier that allows that quicker convergence of the spanning tree protocol. Looking at our RSTP port states again, here on switch 2 has an alternate port. That alternate port has the alternate path to the root bridge. Once again, from S2 to go to S3 and then back up to S1 when the connection between S2 and S1 goes down. Backup port down here is on a shared medium. Basically, you're looking at something like a hub. Now, we don't see backup ports a lot in today's network because hubs are considered legacy devices. We don't use them. Hubs have lots of problems with congestion and flooding and all sorts of stuff like that. Typically, we use switches, so we don't see a lot of backup ports in today's networks. When we connect devices into our switches, they have to go from the blocking to the listening to the learning states. And once again, the default here is 15 seconds each. So it has to wait 15 seconds to go through the listening state, it has to wait 15 seconds to go through the learning state. That's 30 seconds. The problem here is some DHCP clients time out before that 30-second mark is hit. If a DHCP client doesn't get an IP address in 20 seconds or so, some of them will time out. What we can do here is we can turn some of those ports on the switch, those switch ports, and we can say we're going to turn on PortFast. What PortFast does is it transitions from blocking to forwarding state immediately. It goes from blocking to forwarding. You need to be careful where you do this. Use PortFast only on access ports where you have end devices connected in. if you use PortFast on a switch or on a port that's connected to another switch, for example here, a port where you're going to receive those bridge protocol data units, it's going to give you an air disable mode. It's going to recognize, hey, I got a BPDU in here, there's PortFast on there, something is configured bad on our network. We shouldn't have that happen. And so PortFast, you connect up to end devices on your access ports. Never connect them up to a switch. PortFast transitions right from blocking to forwarding immediately. It doesn't go through listening or learning states. As we talk about spanning tree protocol, the idea of having redundancy at layer 2, but yet not having all of these loops happen, it's growing more complex. Back when it first came out in 1998, our networks were not as complicated. Redundancy was a couple switches, a couple connections. Now, in today's networks, you're looking at not a handful of switches. You're looking at hundreds, if not thousands of switches, thousands of VLANs on some of these big networks. How do you handle all that? How does spanning tree handle that? Now, spanning tree has adapted. It added redundancy, it added complexity. We went from normal spanning tree to rapid spanning tree. Cisco's put their own twist on it to even optimize it more. But we still need fast and predictable convergence when there's a failure. If something happens, we need to know that it's going to be fast, it's going to be predictable. Layer 3 has routing for redundant paths. It's built into it. It knows that if this path gets congested, we're going to take the other path. If there's a traffic jam, you're going to drive around it. Layer 3 knows that. Layer 2 doesn't. If that connection's up, we're going to force data through there until that connection goes down. Then we're going to take the alternate network. But layer 3, it can be sort of predictive at times. Now, what's coming in the future is not necessarily an alternate to spanning tree protocol. It's more of a change in hardware at the base level. And what we're going from is layer 2 switches that just dealt with MAC addresses, spanning tree protocol. We're going to layer 3 switches that also do routing. And because it does routing, we can run protocols on it. And then we can see when congestion is starting, let's route around it to alleviate those problems. And so in today's world, yes, there's different versions of spanning tree. But what we're seeing is spanning tree isn't able to keep up with the changes, with how complex our networks are getting, the demands, the redundancy that's needed to make your networks function. And so we're seeing that layer 2 switches are getting replaced with layer 3 switches that operate like a layer 2 switch, but they also have routing built into them. And that's where we're seeing the networks starting to go. And that's what we're seeing is replacing the spanning tree protocol now is layer 3 switches with routing. It was my pleasure to provide you with this wonderful episode on spanning tree protocol. If you like this episode and you got value out of it, and depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com, and you can get all these episodes in video and podcast form. In the upper right is my playlist for my series on switching, routing, and wireless essentials. In the bottom right is one of my favorite episodes that I linked just for you. Thank you so much for watching this episode of my series on switching, routing, and wireless essentials. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.